Okay, welcome back. So picture this. What if I told you that a multi-million-dollar, hyper-efficient energy system often breaks down because of a tiny mistake, a mistake you could literally fix with a screwdriver? It sounds crazy, right? Well, today we're diving into something called combined heat and power, and we're going to uncover the one little detail that can make the difference between huge savings and a really, really expensive paperweight. So let's just start with a really big idea here. What if you could somehow get twice the value out of the fuel you're already paying for? I'm not talking about some futuristic tech. I'm talking about simply capturing the energy that, right now, is probably just getting tossed out into the air. And that right there is the promise of a technology called combined heat and power. You might see it called CHP. So how on earth does it work? At its core, a CHP system is a master multitasker. It does two big jobs at once. First, it generates electricity right there on site, usually with natural gas. But, and this is the magic part, instead of just letting all the heat from that engine vent out uselessly, it actually captures it. And it doesn't just capture it, it puts that recovered heat to work. Now, depending on the building, that thermal energy can be used for space heating or for providing all your hot water. And believe it or not, it can even be used to run a special kind of chiller for air conditioning. You're getting useful work from energy that a normal power plant would have just completely wasted. And this chart, this is where it all clicks. Just look at that difference. A regular power plant, you see it there on the left, wastes more than half its fuel as heat. But a CHP system, by grabbing that waste heat, it can hit 80% efficiency, sometimes even more. It's literally twice as effective. That is the whole ballgame. So CHP sounds amazing in theory, right? A total no-brainer. But here's where things get a little tricky, and it's where a lot of these projects quietly fail to deliver. There's a hidden problem that engineers have a name for. They call it hunting. The whole issue starts with a really simple component, the power sensors. They're called current transducers, or CTs, and their job is just to measure how much electricity is flowing. Now, the standard way to install these, the way most people do it, is to stick them right where the power grid connects to the building. And the logic, it seems sound. You just measure the power you're buying from the utility and tell your generator, hey, get that number as close to zero as you can. What could possibly go wrong? Well, it turns out a lot. The end result of that setup is a system that ends up, well, as the slide says, chasing its own tail. The generator ramps up, the grid power drops, so the controller says, great, we hit the target, but then it overshoots, so it has to back down. Then grid power creeps up again, and the controller overreacts, starting that whole crazy cycle all over again. This unstable cycle is what engineers officially call hunting. The generator's power output is just constantly oscillating. It's swinging up and down, wildly whipping around its target, instead of just holding a nice, steady, efficient state. And listen, this isn't just some minor wobble. The consequences are actually really severe. When the generator overshoots, it can try to push power back onto the grid, which of course instantly trips a safety breaker. The whole system just shuts down, and that means lost savings, someone has to go manually reset it, and you're putting incredible stress on some very, very expensive machinery. It's a total recipe for failure. So how do you solve such a deep, fundamental problem? Well, this is the best part. It turns out the solution is almost frustratingly simple, but it is incredibly elegant. The fix is to just move the sensors. Yeah, that's it. Instead of measuring that tiny, super jumpy amount of power coming in from the grid, you move the CTs to measure the building's total electrical load. You stop trying to control the grid connection and you start responding to what the building is actually using. It's a night and day difference. I know, it's just a small change in wiring, but it completely changes the system's behavior. So let's break down exactly why moving a little sensor has such a massive impact. Okay, so this one simple change gives you three huge benefits. First, and this is the big one, it breaks that chaotic feedback loop. The generator is now listening to a stable signal, the building's total demand, not the twitchy signal at the meter that it was causing itself. Second, it dials down the sensitivity. Trying to hold a value near zero is like trying to balance a needle on its point. It's almost impossible. But measuring a big, relatively stable building load, that's way, way easier. And third, it lets the modern digital controls do their thing, using software to stabilize everything and make the whole system way smarter. All right, so we have a simple fix and we know why it works in theory. But what does this actually mean in the real world? What's the payoff look like? 50%. That's how much energy consumption was reduced below projections in one school district after they made this one simple fix. 50%. That's not a small win. That's the difference between a project that saves millions of dollars and one that's a complete failure. And I love this slide because it illustrates the difference perfectly. Before the fix, the system is like a roller coaster. It's jerky, it's inefficient, and it's super stressful on all the parts. After the fix, it's like driving on a flat, open highway. Just smooth, steady, and incredibly efficient. You have the same engine, you're using the same fuel, but the outcome is completely different. So here's the bottom line. With the sensors in the right place, those surprise shutdowns, they disappear. The wear and tear on the equipment plummets, and for the first time, the CHP system actually gets to do its job and perform exactly the way it was designed to in the first place. And this brings us to what I think is the biggest takeaway of all. The placement of these sensors isn't just a footnote in the installation manual. As it says right here, it's a load-bearing detail. The success of the entire system, all that technology, all that investment, it all rests on getting this one simple thing right. And that leaves us with a final thought. In our hunt for efficiency and smarter technology, it's often not the big, flashy stuff that makes or breaks a project. Sometimes it's the smallest details that we overlook. So the question to ask is, what seemingly minor detail out there could be crippling your system's performance?